Hello, this is Dr. Oz. In this video, I would like to show you how to do capacitated plant location problems using Excel. And these are the problems where angel multi-billion dollar investments where to make these decisions, location decisions is very important, and that's why we use this kind of models. So first of all, what I would like to do is go to 1.8 capacitated plant location problem. And then here, uh, I would like to download the data. Three dots, download the original file. Then once it's downloaded, you can open the file and can click on enable editing. So you can see in this file, we have 13 countries where we can produce things. And also we have demand locations, which are 13 locations as well. And these are the costs for each edge that's connecting those origin nodes to destination nodes. And you can see we have demands for this product that we have at each of these countries. And then revenue is per unit wise is $100, and production capacity for each of those origin nodes are right here. And then the production fixed cost, if you decide to create a facility, production facility in one of these countries, we need to spend these fixed costs correspondingly. And if we make any profit from these 13 countries, we need to pay different tax amounts depending on our profits. And these profits are calculated based on production location. Okay, so now let's get started. First of all, I would like to build my model underneath, and I would like to start with my objective function value. So step number one, which is I would like to give some space, objective function value. And the objective here is, since I give you guys revenue as well as some cost, I will try to maximize profit, which is maximize profit, which can be calculated based on revenues minus expenses. Okay. And I would like to calculate this value, revenues minus expenses, right here underneath this objective. And then my decision variables are how many units should I ship from each of these origin locations to each of these destination locations. So that's my objective. So to be able to do that, I will just copy this area right here, Control C, and then I will just paste it right here, Control V. And these are not going to be shipping costs, these are going to be flow in a number of units. And I would like to delete all these values because instead of dollars, I will have flow amounts. So I like to use decision variables as yellow cells. So these are my decision variables. Okay. And also, I would like to decide which facilities to keep open or close. That's why I will create another decision variable here, which I will call open or not. Okay. These are yellow cells too. Let me use a different type of yellow cell so that we are not confused. They are both decision variables, but these are 0, 1 binary decisions, and these are number of units decisions. Okay, now the third component of an prescriptive analytics model is to decide on constraints. And constraints have left-hand side and right-hand side values. So if you look at this, demand is one of our constraints. So what I would like to do is I will create a demand constraint for each demand location. So right underneath here, shipment to versus shipment, like demand amounts. Perfect. So demand amounts are given right here. Then I will just write down corner, black cross, drag it. I have 13 of those. And in this problem, we assume that we can sell up to these amounts. So we cannot sell more than demand. But we may end up selling less than demand if we don't have enough capacity. Okay, so that's why this is less than or equal to constraint. We can sell up to those limits. I like to use the red color here. And then left-hand side values will basically will be all the shipments to Australia. Sum of all these yellow cells. And then these are all units. So I will just click on under home tab, comma, and I don't need to show decimal. So click over here. So you can see this is the column sum. So right down corner, black cross, I can just drag it. And currently I have no shipment. So let's say if I randomly put 3 units here, you will see that that will appear there. Okay. So now what I would like to do is also create another set of constraints where it's going to be related to the supply side production capacity constraints. So what I will do is create them right here. Shipment from versus capacity. Okay. And capacity values are given right here. And I will drag it down. 13 of them as well. And then capacities, again, we can go up to those capacities, but we cannot exceed available capacities. And I will here, shipments basically will be all the shipments from Australia. So this row sum, click on that cell, right down corner, black cross, drag it. Okay, for this example, 3 and 2, so those are shipments. That's good. And now what I would like to do is create another constraint. In this problem, assume that we have a constraint where our company policy, we would like to be in one of these 3 countries, India, Mexico, or Turkey. So let's say our company policy is that we would like to be in one of those countries for sure, but not more than one. So that's why it's an equality constraint, because if you want to be exactly only one country out of these 3, so if I look at decision variables for India, Mexico, and Turkey, India, I'll just go open close decision for India plus Mexico right here plus Turkey. Perfect. So I want one of those country values to be open. And currently none of them are open. So let's say for fun, if I just plug in here, Turkey is open. And you can see this constraint is satisfied. And then let's say we have another company constraint where we do not want to be more than 5 countries. So up to, let's say, 5 countries constraint. The right-hand side values will be 5, obviously. And this time it's going to be less than or equal to, because we don't want to be more than 5. So we can go up to 5. So 5, 4, 3, 2, 1, or 0. So when we sum all of our open close decisions, they should be less than or equal to 5. Perfect. So now we calculated our constraints, and we just determined our objective and decision variables. Now we need to calculate the um, objective function value. And I would like to record a separate video for that. So this is part one. In part two, I will show you how to calculate this and run the solver. That's it for this video. Until next video, enjoy analytics.